Good morning or afternoon or evening, everybody, depending upon where you're located. So I want to give you a little bit of information on myself. Um, so I have a PMP certification, that's Project Management Professional from the Project Management Institute. And I'm a senior informatics consultant at CSOLS, as Megan indicated. And so over the time of my career, I've specialized in a number of areas, but probably at this point, my biggest specialty is pharmaceuticals and regulated industries like biotechnology, as well as project and program management and other strategic consulting on system implementations and long-range roadmaps. So I got my first degree in chemistry and started with 5 years in an analytical lab doing testing and the typical kinds of bench and instrumentation types of activities you do as an analytical chemist. And then I got an advanced degree in systems management. Got my project management credential about 15 years ago. And over the past 25 years, I've been more on the IT side of laboratories, but still focused on laboratories, working in a variety of areas. I implemented the first LIMS system for a major biotechnology company. And in the last 8 or 9 years, I've been consulting initially independently and then for 7 years with CSOLS. So it's about 6.5, it's almost 7 years at this point with CSOLS. So that's my background. I just wanted you to have a little bit of that overview. So today I want to talk about a few things related to this excellence in laboratory informatics discussion topic. So we want to start by talking about what an informatics project is, and then talk about, well, okay, but what makes a project excellent? And I obviously, there's no right or wrong answer here, but I have certain opinions on what makes a project excellent, and I wanted to share some of those historical experiences with you on that. I want to talk a little bit about traditional project management and then project leadership and what would differentiate those two things. And then how do we really find the right skill sets to provide project management and project leadership on our informatics projects? And what skills do we really need there that help differentiate the excellent project from the not successful project or just the sort of minimally successful project? And finally, I'll have a summary, and then we can do some Q&A as needed. So I wanted to start by talking about an informatics project sort of from the beginning in terms of the definitions here. So if we look at Wikipedia, their definition of informatics says that it involves the practice of information processing and the engineering of information systems. So in this talk, I'm talking about laboratory informatics, but in terms of the definition here, informatics doesn't need to be laboratory focused. It could be covering all sorts of other information systems and information processing areas. And a project, according to the Project Management Institute, is a temporary endeavor, so it's not going to last forever. And our product that we're going to create is unique. It could be a product or a service or some result, but there's some sort of an output from this project that's unique. And I can tell you that in implementing laboratory informatics projects, even using the same software product, since every lab is different in terms of scale and what they do and the tests they do, every product is unique, even if in terms of an implementation, even if the actual software product is the same in some cases. So then if we put those together, an informatics project is a temporary endeavor that we take to engineer an information system, and our intent is to create the unique product or service that's needed in your laboratory. And that's where it differentiates itself from anybody else's laboratory because of the unique aspects of your laboratory environment that may be different than any other lab. So the other thing is that when we talk about an informatics project, is we don't want to sort of, technically speaking, if I was going to implement a simple instrument, you could call that a project, but I'm really talking about the broader systems here, the ones that have significant impacts on a lab or its operations. So typically those follow into one of the 5 categories you see here. And this may not be the sort of only list of things that could be included in this definition, but these are the most common things we see. So a LIMS organizes samples and results and can help produce reports more effectively and help make a lab more efficient and gather laboratory metrics. Whereas an SDMS is often used more in a less structured environment, typically R&D, and that's something where all kinds of different paperwork and data can be collected and stored almost as if it's a document management system for this laboratory environment. And that enables you to retrieve that information really quickly and easily and can provide significant benefits. Chromatography data systems are a little more bench level, and they not only collect data from chromatography systems, could be gas chromatography, HPLC, any of those types of systems, but they typically also store methods, and they enable you to centralize methods in the lab if you have many, many similar chromatography systems. And then these systems actually control the instrumentation themselves. So there's sort of a bidirectionality to that, which adds a lot of efficiency in terms of gathering the data. The ELN really substitutes for the laboratory notebook and enables you to sort of electronically do what you might have done on paper, maybe with some simple calculations and those types of things. But for a higher volume environment and you want a more rigorous way to do processes, you would use more of an LES, and that can really help reduce errors and provide a lot more streamlining of automation in a higher volume laboratory bench level set of exercises. So these are the types of systems that tend to be broad-based in a laboratory. They impact a lot of people and a lot of functions, and so they are more complex projects that we see in informatics in the laboratory. So now let's talk about, we want a successful project. And there are 3 key factors that are typically talked about when we talk about project success. And one of them is obviously that we want the project to complete on time. Often management is going to say, you know, we need this system put in by December, for example. And then we also want this project to be on budget. So that often, if you're procuring software, hardware, maybe consultants, maybe you're tracking internal labor as well, depending upon the company, you want your project to be on budget and on time. And then perhaps most importantly, there's a certain set of functionality you expect out of the system that you're putting in place. The project's unique product has to deliver the functionality you really expect and want. Or if you don't do that, the project is not successful. So these 3 factors together are the sort of very traditional project management, what we sometimes call the triple constraint, where we vary these items to deliver everything we want, and typically one of them has an impact on the other 2. So this is what traditional project management manages. And when we put all these things together, this is what is traditionally looked at as a successful project. We were on time, we were on budget, and we had the functionality we had desired, so we have a successful outcome in terms of our project. So now, the whole topic of this talk is we want project excellence. And okay, well, we have success in the scenario that I just talked about. What makes a project excellent if not success? And so what I'm about to show you is my own take on this. Obviously, there's no right or wrong answer here, but I'll propose to you that there are other factors that we could add to this success list that could help make a project excellent. One of them might be technical scalability.